much indeed. Are we okay to crack on? Everybody can see my screen. All looks good.
Yes, I can see it.
Perfect. Thank you very much. Yeah, well, I hope everybody is keeping safe and well and enjoying the event so far. My name is Dexter Barnes. I have short brown hair and I'm currently wearing a check shirt. I've been a software engineer at Thoughtworks for the last 3.5 years, and I'm joined today by Martin.
Hello, I'm Martin McCaffery. I'm a developer with Thoughtworks. Moving into the infrastructure space now. I've been with Thoughtworks for a couple of years. I'm wearing a blue and orange jumper thing and glasses, short brown hair.
Thank you very much. So Martin and I are going to talk to you today about data pipelines for creating seamless data stores. Martin will go into a bit of the background and context in a minute, but this is coming off the back of a recent project that we just completed. It was our first foray into the kind of data world. Martin and I were predominantly web developer background, so it was really interesting to kind of see how our usual day-to-day kind of development processes would fit in with the data world. And so just before that background and context, I'll just give you a little bit of kind of what our mission statement was for this project. So it kind of boils down to this. We were to gather varying data from different sources into stores that could be seamlessly queried by the business to support decision-making and day-to-day monitoring. So I tried to highlight here just basically the key bits that we pulled out of our mission statement. So it was varying data. We had lots of different sources, but we needed it to be seamlessly queryable by the business so it didn't interfere with their normal day-to-day processes. So with that, I'll just pass over to Martin to go into a little bit of the background and context.
Thank you. So yeah, the company that we were working in was a relatively small business. It was an insurance company based in London. So it was around 10 years old, and since it had been created, it had been working in the home insurance market and only home insurance. Its big thing was specifically that it focused on data. It tried to use the data that it could gather about its customers and the market to tailor its products very precisely. So they built a system for that, an in-house platform that they'd been working on and refining and honing for quite a number of years. And they were quite pleased with it until they decided to grow into a different service line, car insurance. So they acquired a subsidiary which worked in that area. That subsidiary had obviously a completely different data system under the hood and just worked rather differently, but they wanted to keep that analysis focus. So in order to bring the two systems more in line and more kind of compatible, they brought us in. So this was a team partially from Thoughtworks with me and Dexter, and partially from the client, so co-sourced. We were a normal kind of developer team. There were 7 or 8 of us in total. So the environment we were working in was, obviously we had this in-house system that was quite sophisticated, and we had the car system, which was a completely separate world, built partially by the subsidiary firm, but also relying heavily on data from a third party that they kind of relied on for much of their heavy lifting. There were 2 kind of clients that we were working for within the business. We didn't work with the external customers at all. We were just working with the analytics and the reporting teams. So the analytics team were quite happy with the existing system, but they simply just did not have access really to any of the data from the car world, from the subsidiary. What's more, what data they did have wasn't really in the same format, didn't really use the same vocabulary, the same concepts as the data in the home insurance world that they were used to. So those were quite some pain points. And then the reporting team had, similar pain points. Those are issues for the reporting, but also they didn't get the data very frequently. So reporting, obviously, you have a minimum level of reporting you need to do for government regulation and so on. But in addition, you want to be able to just see what's going on moment to moment. That they just simply did not have. They'd be getting emails every day or even every week, summarizing some of the information in whatever format those emails came. So there was quite a lot of pain, for which our goal was to consolidate it. So to basically make both of these teams able to access the car insurance market, the car insurance product, through the software that our team would be creating in exactly the same way, pretty much as possible. as they would access the home insurance world. So they'd be dealing with the same concepts, the same data structures, they'd be using the same access as much as possible, and they'd be getting that data in real time or as close to real time as reasonably possible. So between those two teams, there were a few different uses of the data. We had report generation, as mentioned, so that would be potentially, yeah, every day or every week they'd want to come up with nice kind of PDF type reports, but also there could be more kind of exploratory things, ad hoc questions. How come we just had that big sales downturn last week? Or how are we doing for this particular demographic, for example? So lots of different things that they might be doing at different times. Also refining the quotes, obviously that's a big part of having a big data model in the insurance world, is refining what you're actually selling, how expensive the policies are, who's actually eligible for them, and so on. And of course, you want to know that the policies that you've created actually are being sold as you intended. So just getting the data back and knowing that, okay, we said that for someone with these characteristics, we would sell that policy for £100. Are we actually selling that policy or that type of policy for £100 to people with those demographic characteristics? That's kind of essential. And they just did not have that information. And then last but not least, dashboards. So this is the more real-time question. They had a nice little Java app that they'd been building for the home insurance world, which had a load of different kind of sections, allowed you to see different daily, weekly pieces of information about different kinds of sales from different sources, different areas. And that, for the home insurance market, was basically, that was real time. That was just as a thing happened, it would appear on the dashboard. And so you got nice moments like the call center would be able to have a little cheer when they made a lot of sales in a short amount of time. And obviously that simply wasn't part of the existing system that we inherited. So there were three challenges when we were working with this, which kind of relate a bit to the concept of big data. There was obviously, yeah, different ways that we were going to be consuming the data, as I mentioned, so refining quotes, reports, and the real-time dashboard. There were also different sources for the data, different places we were getting it from. So obviously there's the primary system that the car insurance subsidiary was using that provided a lot of the information in different structures, different places. But then there was also, well, internal systems, more to do with the home world and just kind of business internal things, and also global systems. So insurance is obviously not a world unto itself. You need, in order to sell insurance, you need to understand the demographics, you need to understand who the people are that you're selling it to, you need to understand the risk. So there are companies like LexisNexis that we worked with who provide information on demographics, how many cars have you had in the past, maybe criminal convictions, and also credit ratings and that sort of thing. So they would provide data in their own ways, and we'll come back to that in a little bit. And then there was different types of data. So most of the data, or a large chunk of it, was relatively nice and simple batched data. So you just say, okay, we sold this many policies in the last 20 minutes. Let's just kind of tidy them all up, restructure the data a little bit and make it available. And then you get enhancement data from these global providers, which will be of slightly different structures in that. So LexisNexis, as we'll be talking about later, they work on a model where you send off a request to them saying, I want information on all of these people, please. And then at some point, maybe a day later, they send you back a big document, XML, so a little bit of an archaic structure, saying, here's the information on all of those people. So that's quite a lot of information and quite a range of different pieces of information within it. So that created some interesting challenges. And then also there were derived concepts, so things that weren't actually present in the original data that we'd be receiving. So where you might get the data of, okay, these many quotes have been given out to people. You start saying, okay, but what was the actual best quote for different people? What was the first quote that people were given? And then last but not least, we had one more issue, which was we weren't really experts in any of this stuff. As Dexter mentioned, we are developers, web developers. I come from an academic background. We were not particularly au fait with the world of data or the world of cloud computing, which were very much the worlds we were needing to inhabit for this sort of thing in order to get scalability and simply data processing power. We were able to access people who knew about these things. We had obviously a very sophisticated analysis team within the client organization who were able to kind of talk through what they needed about the data, but not so much how to get it that way. And there was a platform team as well that we were able to work with fairly closely. So we did have access to the information, but we fundamentally were kind of feeling things out on our own and trying to work out our own kind of best practices as we went. So that's the environment that we were working in. So back to Dex for how we actually did it.
Thank you very much. Yeah, so we move on to kind of the implementation side of this. So as Martin mentioned, we had a kind of standard team structure. We started with 2 pairs, co-source pairs, which eventually ramped up into 3 pairs. And we had business analysts, quality analysts, and a project manager available to us as well. Because of the way that we're working in pairs and that we had multiple pairs, we had the understanding that we wanted to be able to run that in parallel. So we wanted those pairs to be able to work on independent pieces. And vaguely what we kind of ended up with was like a 4-phase kind of approach, so which is what I'll go through now. So phase 1 was batch data. Phase 1 actually had 2 kind of key activities as part of it. As Martin said, we were kind of figuring some of this stuff out. So at the beginning of this phase, we wanted to basically answer a few questions we had. One was around the technical architecture of how we want to implement this. One was around the technologies that we wanted to use. And then one was kind of how we were going to put those together to build an environment. Going to the technologies first, the client we were working with was already heavily involved with AWS. So that was a relatively easy question to answer, that we would be using AWS. They already had some in-house kind of tools that they developed that helped with deployments and resources. So that was really useful to help at the beginning. But a couple of the other things around technologies were we wanted to see what AWS offered now. And one of the technologies that they started to offer was Glue, which is their ETL technology for extraction, transformation, and loading. So we wanted to look in to see if that would be a possible fit. We then looked around the kind of technical architecture. As we were coming, as we said, from a kind of web developer kind of background, and we do all things microservice, we were wondering whether that would be something that we could implement in this world as well. And as you can see on the right-hand side, there's a very simplified diagram of kind of what we wanted to achieve and whether this would be possible to achieve. So we had this idea of a 3-layered approach. So we have an ingest layer, a pipeline layer, and a warehouse layer. And that would then form a vertical slice through, which we would then dub a pipeline for us. And each one of those areas would then be independently deployable. There'd be their own repository with their own resources, which would hopefully allow us to then interchange them, deploy them independently, fix bugs independently, and so on. The other part of the kind of phase 1 was taking these kind of decisions and then seeing if we could develop some spikes or some proof of concepts to try and validate some of these assumptions. So we dedicated a good couple of weeks, the first iteration, to kind of spike some proof of concepts. Not only did it help validate some of those answers and the architecture and the technologies, but it also just kind of brought us all up at the same time within the team into the same understanding of what we were going to try and do. So the next phase, next activity in phase 1 was trying to do something that we would usually do in a development project, which is set up a walking skeleton. A walking skeleton being that kind of very slim but functional slice all the way through your system from start to finish, to both find any unknown unknowns, to prove any assumptions, to make sure that the infrastructure is looking good. And that's something we wanted to do here. So our batch data that we kind of earmarked for this was policy data. Policy data for us was something very simple as a concept. So when you have a customer that fills out a form and they submit that and they receive a quote, if they subsequently purchase that quote, that becomes a policy. That is like the tangible item that you can kind of envision very easily of something that lasts a year. So what we wanted to do was be able to pull that policy data out of our third-party system via our ingest layer, put it into our pipeline layer, which we'd be using Glue for, which would then be able to transform it and then load it into our warehouse layer. And as soon as it gets into that warehouse layer, it's then available to our clients within the business to then start querying. If we had that structure set up, that would prove a lot for us. And it also allows us, or offers us, to set up the end-to-end tests. We knew that some of the glue technologies were quite infant, they're quite new, and there wasn't a lot around how to test them. So we wanted to make sure that we could have our end-to-end tests up and running early to give us that kind of safety for then developing on top of this. One of the cool things that was actually coming out of phase 1 that we noticed quite straight away with the glue technology is it uses a data catalog as trying to kind of outline the structure of data that's the input to the glue transformation itself. What this actually allowed for us is that between that ingest and pipeline layer, using that data catalog as almost like a contract. It's almost like an API specification. And that actually answered that question from before about how could we do this in parallel. Well, now we could have a pair working on the pipeline to a data structure by that data catalog, and have another pair working on the ingest, as long as that data being output from the ingest followed that data contract as well. So this phase 1 was really beneficial for us. So at the end of phase 1, the value that we had was we had a very simple walking skeleton structure to our application. We'd been able to validate our architecture was going to work to how we needed it right now. We had the end-to-end test running. We had data flowing through our system, and we were able to deploy that in a timely fashion. So that moves us on to phase 2. Phase 2, what we really wanted to do was be able to build upon phase 1, allow us to kind of check that what we were doing was going to be fit for purpose. And one of the other things that we wanted to do is actually have the idea of what we would do in a normal web application is the MVP, or incremental delivery, for some value that we could give straight back to the business. As Martin explained, our dashboards were a key part, or are a key part to the business. They were viewed by managers on a daily basis. They were viewed by the customer service team on a daily basis. They would keep it open in a tab in Chrome, and they would refresh it and keep an eye on it as they went. So this was really familiar to them from their normal home insurance. So we wanted to be able to give this to them early on as possible for car insurance. So on our right-hand side here, we have a very familiar now architecture diagram, which was our ingest layer. But this time, our pipeline and warehouse, we were able to substitute in our kind of next bit of the microservice-y world. We had a pipeline version, which was a Java application. This was something that was already running for their home insurance, and we could fork and then tailor it towards car insurance. And we had a very simple MySQL database as the warehouse that would store the aggregated data, which would then be offered via that Java application for a RESTful API. So we were able to, as part of phase 2, validate our architecture. It was very simple for us to set this up. We were also able to start doing some of the normal processes that we would do, showcases. We were able to involve the business early on. We were able to demo this very easily. It was very visible to them, and it was very familiar. And we'll also be able to flag this as a possible MVP. Because this was so separate and it was a defined pipeline, we could deploy this live and get it in use. On those dashboards, they kind of show a lot of different data. They have sales data for kind of on the day, the yesterday, 4-day average, 7-day average, but they also showed other metrics such as renewals. When a policy reaches the end of its life, if it gets renewed, they would show that metric too. But for us, that's incremental. We could easily show how many were sold in that day, deploy that live, get it in use by the business, receive feedback, and then have the potential to build on that incrementally. So at the end of phase 2, we now have our batch data not only serving our Redshift platform, which we would then allow our analytics team to query it as a normal database, but that batch data was also going through another pipeline, which would then be aggregated to be displayed on the dashboards. Martin, I'll pass over to you for phase 3.
Yeah, thanks. So what Dexter's been talking about thus far has been kind of setting up the fundamentals of our architecture, getting the batch data processing, getting showcases, doing a lot of spiking, and kind of working out how things would go. By phase 3, we were moving on to some of the more funky aspects of the data, which comes to enhancement, basically. So the enrichment or enhancement data that I mentioned earlier, coming from companies like LexisNexis. This had one or two different ways in which it differed from the batch data. Mostly it was because of the structure. So because it was broad information, especially for the background, the demographic information, we didn't know how many previous insurance claims there would have been, how many previous cars. We didn't know what information would be relevant to those. So the specific data contracts that Dex mentioned earlier actually became a bit of a negative in this world, because we didn't want to have to say in advance what structure the data would be. However, this actually turned out not to be so much of an issue as a nice way of proving out our design, because we were able to use a related technology, Redshift Spectrum, and basically just create a new pipeline system, a new line along our architecture, using S3 buckets, using a different technology to process the data without needing to know what structure it would be. So specifically, we started out with some of the information from the third parties, like the subsidiaries' primary third party, the nice close by world, that we could just read in through glue, but then we would need to write that out using, well, so the way basically that we found to not have to write it out using an actual database system was actually just a rather nifty AWS offering called Spectrum, Redshift Spectrum. So this is sold as part of Redshift, but basically it involves you write data into S3 buckets, so Amazon's kind of storage in the cloud, and then Spectrum has the notion of, or Glue has the notion of crawlers, where it looks through the S3 buckets, it looks through the data that you've put there, and just calculates, works out what the structure is, tries to come up with a specification for that data that matches all of the information that it sees. And then from inside Redshift, you're able to simply say, I would like to create an external schema, as it's called, which literally points to that catalog, which in turn points to the S3 bucket, which means that you can simply query the data through Redshift, just the same way as you would just query information that was put there in a more standard way. Specifically, actually quite nicely, you could query both information from standard Redshift and information from Redshift Spectrum in one breath, in one SQL query, if you wanted. So this was very nice. This allowed us to bypass the need for data catalogs, print things out into S3 buckets, and even for the LexisNexis data, go a little bit more wild. The issue with LexisNexis was, as mentioned earlier, that it was very large data and very, very varied. Like we had no idea what was going on in it. But so for that, we actually just decided to simplify everything down. And instead of using Glue, which is kind of based on Apache Spark and has a lot of powerful data manipulation tooling, we simply used Amazon's basic functions in the cloud system called Lambda to read in the data, tidy up a bit of the metadata, and then just spit it straight back out again in a different, more easily accessible format. And that was completely fine using our system. It was actually quite pleasant. We were able to just, use both of those, set those up alongside the more traditional aggregate Glue information. So the business value at the end of that was that we now had a bit more of an idea of what was going on. So we started out with, we know that we have sold this many policies in the last 10 minutes, but that's nice, but that's not really meaningful until you can start saying, we sold these policies to these people, these demographics. Then once you've got that information, you can start really doing good processing. You start really tidying your algorithms, tidying your policies, and growing the business meaningfully. Going on then from that to our most complicated data in some ways, was the derived data. So rather than the information just simply being there and then we would process it and then we would make it available, this is data that is only kind of there by implication. So the example we mostly were working on was best inquiry. So an inquiry in the insurance world that we were in is when you say Joe Blogs wants to buy some insurance. So he goes to a website, maybe moneysupermarket.com. He enters his details, fills in a big form, sends it off, and then receives back a load of quotes. Those quotes, each of those numbers, count as an inquiry, basically. So we want to know, well, for one thing, we do just want to know how many inquiries have we sold, or how many inquiries have we responded to. So how much money would we have made if we'd sold all of the inquiries that people have requested. But we also want to process those. We also want to work out maybe the best one. So for a given person, what is the cheapest amount that they were quoted by us? Or what was the first amount that they were quoted? Now, this doesn't really fit into the glue model that we were working on thus far, basically because of timing. So with glue, say Joe Bloggs starts making his requests at 5 to 12. He makes 10 requests, or he gets 10 inquiries, 10 quotes. And then at 12 o'clock, our glue system fires, reads in all the data, processes all the data, spits it out and says, okay, Joe Bloggs made these 10 requests, received these 10 inquiries. And then Joe Bloggs continues and makes a few more inquiries at 5 past 12, perfectly reasonable. There's no reason why he wouldn't. But then kind of from our processing, from the glue point of view, we've suddenly got 2 instances of Joe doing different things. It's not really representative of what's actually happening. So the solution to this came in the form of another AWS technology. I apologize if this feels like an advertisement for Amazon. This technology is called Amazon Kinesis. It's quite widely used, and it allows this sort of flexibility. So the format of Kinesis is you read in the data into a stream. Kinesis stream is just kind of a generic holder of data. And then you write, well, you can write from that stream to multiple places. So in the simplest case, on the top line of this diagram, you simply write that data out using Amazon's Kinesis Firehose, which is just a writing tool, basically, into maybe an S3 bucket, which is then read by Redshift, or directly into Redshift, however you want to do it. So that's fine. And then you can start saying, okay, how many inquiries did we get across this hour-long period or whatever? You can start doing broad level analysis. But then you can also read the same stream into an analytics application, which looks basically like a slightly more complicated SQL query. The complicated bits are actually the very cool bits. So they allow you to specify, for example, an ID. So you just say, rather than here is some data, there's just a load of inquiries and each one is distinct. You start saying, okay, but what I care about is grouping these by a risk ID, for example. So basically a customer ID, proto-customer ID. So you'd be able to say, group by that, and then do this on aggregates of that data. So you'd be able to say, okay, I would just like to look now at Joe Bloggs and keep his data separate. And maybe someone else starts firing queries 5 minutes later and finishes 5 minutes earlier. Doesn't matter, that's a separate ID. So with that, you can, well, it's very easy. Once you've grouped things according to customer ID, you can start just saying, well, in that case, I would like the lowest value that came in, please, or the first value. And then what you do with that is you spit it out into another Kinesis stream, which you then put out into Firehose and you write it into Redshift. Or indeed, you can put that back into another analytics application and start tweaking that in different ways. So the beauty of this system was, well, on the one hand, that it allowed us to do what we needed to do, which was aggregate these things without having to worry about kind of timing and all that sort of thing. But also we built a tool, we built a system that could be built on. So we cared about first inquiry and best inquiry, but if the business so wanted, in the future, they will be able very, very easily to deal with maybe the last inquiry. What was the last quote that someone saw before they made a decision? If they want to do that, then they could just use exactly the same technology, exactly the same input, most of the same streams and analytics, and it wouldn't affect any of the existing technology. It would just be another siphon off and would work very cleanly. So we were quite pleased with this. And in fact, that basically rounded out the data that we were providing. So to summarize, once again, we had our batch data and enhancement data and some derived data, all being made available from completely different sources and in different processes, but being made available, all of them, just through Redshift. All you needed to know as an analytics team member or reporting was go to Redshift, the data's there. Some of this was using Spectrum, some of it wasn't. That didn't matter to the end users. But then the other users who cared more about the real-time information on the dashboard, they would also be able to access all that they needed about the summaries of just the batch data, because they weren't interested in the demographics and so on. So basically, yeah, everyone had the information they needed really quite simply. And the architecture we used for that looks really quite complicated, but is not that complicated when you take into account the fact that each of these things is just done independently, could evolve, could break, could in theory be deprecated, or new ones completely introduced using the same technologies or even entirely new technologies with minimal, if any, impact on the system as a whole. So we had a system that was really quite flexible and powerful. So that's what we built, and I'll pass back to Dex for how it was received.
Thank you, Martin. Yeah, so we split the outcomes into kind of two bits here. We have results and some lessons learned. These are some of the key results. I mean, ultimately, what we did was considered a success. We were able to give all of that data to our internal clients via a seamless store. We are able to, I mean, in this case, have quick feedback loops. The abstraction that we did with the layers and then also the pipelines themselves meant that if we found bugs or if we needed to make an update or make a tweak, then we were able to easily deploy those, make the change, deploy those, and then demo it or showcase it back to the clients, and they would be able to then use it and give us our quick feedback. This was really useful for when we were rolling out those dashboards, because the concepts that we were trying to do meant that we could compare it. If there was a slight difference, we could work that out, redo it, redeploy it, and then within 15 minutes, ingested all of that data and the dashboards are back up to date and we could use it again. We're also able to leverage the incremental delivery that we were used to as normal web application development. Again, the dashboards were a really good example of this. We were able to deliver that kind of daily aggregate, then we moved into the weekly and we moved on to renewals. But it actually really worked well at that kind of low level data as well. So just doing phase one and making the policy data available to the business to start querying and using meant that we were able to kind of get that out and in use. There may be some reports, that very standard reports, that might use that data, and then they could start using that with their kind of managers. What we also got were testable pipelines. The testing around this was actually one of the really most interesting parts. Like I said at the beginning, the whole technology around the AWS that we're using was relatively new, and doing our kind of initial spikes and proof of concepts found not a lot of people doing a lot of testing at the kind of integration level. So we were really happy that we were able to get that kind of normal test pyramid up and running. We had unit tests around our Python code, which was the majority of the glue kind of concepts, and we had our end-to-end tests running, black box end-to-end tests running for each of those pipelines that could also do journeys and elaborate on those journeys if we wanted to. And then it was scalable by its design using AWS. We got all of their fun scalability for almost free. We knew that at the beginning of this, their home insurance, you don't tend to get too much kind of traffic compared to car. When you bought home insurance, it tends to be kind of fairly long-lived. But with the car insurance market, we knew we were going to get a lot more inquiries, a lot more quote generation, and then also policies renewing. Then obviously on a year-on-year basis would be a higher throughput. So knowing that we had that scalability behind it, where the glue jobs would use as much as they could to process the data as it came in, which moves us on to kind of the lessons learned. I mean, they were vast. This was our first foray into data, so we were absolutely loving the amount that we were learning. But some key things around the actual project itself, that beginning part, the bit where we were able to experiment with the proof of concepts and the spikes, was absolutely key. We made this very aware or very known to the business when we started, that we were going to use that initial time for doing spikes and those proof of concepts. Which definitely sped us up. We were able to, we had the safety of the knowledge that if we didn't think the glue was going to work, we could throw it away and we could try something else. We weren't pressured into it. It was our decision to make. The abstraction into the layers worked really well. The idea that we wanted to kind of make this microservice-y and that we could then pick up those individual parts and work on them independently worked. And the fact that we were able to use those data contracts as that kind of bounded context API really meant that we could work independently with the safety that we knew that they would click together as soon as we wanted to do it. The usual thing around involving stakeholders early. We weren't sure if this was going to be possible at the beginning, knowing that sometimes when you want data, you need to have that complement of data before you can start using it. and then maybe they wouldn't be up for trying to just look at data that they weren't able to use. But it was actually really key. Being able to involve the different teams with the data they were going to use in the end, giving them that kind of opportunity to use it early, really meant that we were able to take a lot of their suggestions on board. And that was suggestions ranging from, now this data isn't quite correct, that wasn't what our requirement was, but also if we were able to then say, well, actually we had this extra bit of data, would that be useful as part of this? And involving it early meant that they could evolve their reports along with us evolving our data that was ready for them. And then our ordinary development practices still worked really well. Ordinary for us being stuff like TDD. We were able to do our test-driven development on this. We were able to keep pairing, and we were able to pair work on different things using those data contracts, but also using small iterations. We did 2-week iterations, and we were able to do showcases at the end of those iterations and get what we were working on out into the business. And then the idea of having an MVP. Being able to ring fence those kind of business value areas, and then being able to deploy those and give those out early still works, and it was still really, really useful. Yeah, so all in all, it was a fantastic project. We learned a lot, and we welcome any questions that you might have. Thank you very much.
It may not be a coincidence that I've moved into the infrastructure space after this project.